Today we're going to complete lesson 1 from Unit 8 in your new orange workbook. Before we complete the first lesson, in order to be successful, we need to recap a few area concepts. We're going to go over how to calculate the area of a rectangle and how to calculate the area of a triangle, so that way we can utilize those formulas throughout the lesson. At this time, I'd like you to calculate the area of this rectangle and the area of this triangle. You may have a little bit of writing space at the top of page 2 of your workbook in the margin. Otherwise, you can grab a dry erase marker and work these out on your desk. So just a reminder, to calculate the area of a rectangle, our formula we use is area equals length times width. And to calculate the area of a triangle, we use area equals 1/2 base times height, or base times height divided by 2. So at this time, go ahead, pause the video, and calculate the area of these two figures. When you're done, go ahead and hit play. All right, so hopefully when calculating the area of these two figures, your work for the rectangle looks as like this. You use the length times width formula and did 3 times 8. And when you do 3 times 8, you should get an area of 24 square yards. If you did not get 24 square yards, please at this time go ahead and adjust accordingly. Then when you did the area of the triangle, hopefully you input for the base the number 6, and the height of our triangle is given as 5. So since it's all multiplication, you can do it in any order. If you'd like to take half of 6 first, we can do that. And we get 3 times 5, which would give us a total area of 15. And in this case, since there are no units of measurement, we would just say 15 square units. Sorry, my screen is lagging for some reason. Temporary malfunction. Let's try that one more time. Maybe. All right. "15 square units." All right, so now that we've recapped how to calculate the area of rectangles and triangles, we're going to utilize that concept in today's lesson. So let's go on to some problems in your workbook on page 2, so please join me. Our first learning target for Unit 8 is to be able to understand how square roots relate to area and side lengths of tilted squares, and understand what an irrational number is. So we'll get more into that irrational piece coming up in the next few days. Today, hopefully, you should be able to walk out the door being able to find the area of a triangle, find the area of a tilted square on a grid by using methods like decompose and rearrange and surround and subtract. We're really going to focus on this last one, surround and subtract. That one's going to definitely help you be successful for the upcoming units. So let's take a look at our first problem. All right, so at the top of page 2 there, they're asking you which shaded region is larger, and be ready to explain your reasoning. Feel free, if you need to, use patty paper throughout any of the problems in this unit. You know where it's located on the desk in front of mine. Help yourself. So I'd like you to pause the video at this time, use patty paper or whatever strategy that you may have to figure out which one is larger. So go ahead and pause the video now, and when you're done working it out, go ahead and hit play to check your work with mine. All right, well, welcome back. hopefully, after you've messed around with these two figures, you realize that figure B has the larger shaded region because figure A is actually 4 square units and figure B is 5 square units. So some strategies that you may have used for figure A could have been calculating the area of 2 triangles. So if I notice figure A, sorry, like I said, my smartboard is acting up today, is composed of a triangle at the top and then a second triangle of the same size at the bottom. So I could use my formula for area of a triangle and calculate the triangle at the top. So again, that's area equals 1/2 base times height. If I go ahead and count out, there are 1, 2, 3, 4 units across the base. So I can input 4 for my base. Sorry, again, having some technical difficulties. All right, 4 for my base. And then I look that there is 1 unit going up for my height in the red triangle. So when I take half of 4, I get 2, and 2 times 1 does give me an area of 2 square units for the top triangle. If I know that these 2 triangles are equivalent, then I know I can simply just take my answer from the top area and multiply it by 2 since there are 2 of them. So 2 times 2 gives me a total area of 4. So figure A has an area of 4 square units. All right, let's take a look at the strategy for B. A possible strategy that maybe you started with was attempting to count these square units in the inside. The issue we've come into play is that we have these odd size pieces that are shaded in, so we don't really know exactly how much of a square that they take up. Possibly if you use patty paper, you might have been able to better figure that out. So it is very challenging though to try to actually count the squares on this one, and it is a little challenging to try to find two perfect triangles like we were able to in figure A. So what I was thinking was an alternate approach. I do see specific triangles in the figure, however, they're not in the shaded region. They are in what we call the negative space, or the white region of the picture. So, also by looking at these 4 different triangles, they appear to be the same size. And I can verify that by counting the base and the height. So if I take a look at this triangle up top in the upper left-hand corner, I can see that it has a base of 1 and a height of 2 units. I can see wrapping around the entire figure that they all share this in common. Here's the base of 1 and a height of 2. It's just been rotated. Again, base of 1, height of 2. Base of 1, height of 2. So if I calculate the area of one of these figures, I can then multiply it by 4 to calculate the area of all 4 of them. And then the rest of this strategy is that if I calculate the area of the entire white square, I can take away those triangles from the white square, and I would be left with my area or my space left over, which is the blue square. So let's go ahead and do that. Let's calculate the area of one of the triangles. So I'm going to do my 1/2 base times height. Okay. So half of 1 times 2. Again, it's multiplication, so I can do it in any order I want. So if I want to do 1 times 2 first, which I know is 2, and then take half of that, I get half of 2, which is 1. So now I know each of these triangular pieces are each 1 square unit. So this is 1 square unit, this is 1 square unit, this one, and this one. So the next thing I'm going to do is I'm going to find the area of the entire space. So that's this big out exterior square. So if I count across, I know area of a square or a rectangle is length times width. My length all the way across is 1, 2, 3 units long. My length down the side is 1, or my width, 2, 3 units down. So to calculate the area of the large square, I'm doing 3 times 3, which is 9 square units. So I need the blue space inside. I've calculated the entire space of 9 and the white spaces. So now I'm going to take the entire space and subtract the white from it. So I'm going to go 9 minus, oh, it's not 1 because there's actually 1, 2, 3, 4 of them. So it would be 9 minus 4, which gives me 5. So figure B has an area of 5 units squared, or square units. So we can see that figure B is the larger of the two because it does in fact have a greater area. So this is a strategy that can really help you throughout this lesson, as opposed to trying to be able to count, because it doesn't always work. This strategy has a name. It's called surround and subtract, and that's really what I did. I surrounded the blue figure with the white one. I calculated the area of the entire figure, the area of my negative space, which were my 4 triangles, and I subtracted it from the total. So keep that method in mind as we move along. At this time, if you need to update or fix anything on 1.1 in your workbooks at the top of page 2, please do that now and pause the video. If not, you're ready to move on to activity 1.2. All right, so this second activity is very similar, but it's just a little bit more advanced. So our task again is to calculate the area of each of the blue shaded regions. Think about the strategies we just used, finding figures that look familiar and combining them, or surrounding and subtracting when possible. So at this time, I'd like you to pause the video, take one of those strategies, and attempt them with solving the next 3 problems. Feel free to hit play when you're ready to check a problem and correct your notes or add to your notes. Okay, let's walk through problem number 1. So if I want to find the area of this blue figure in problem number 1, I'm probably going to go with the surround and subtract method. Very similar to the last problem we did. Again, I'm going to go with this route because since this blue square is tilted, I cannot clearly count out the length and the width of this blue square. It's going to be very much so a challenge. Or even to try to draw in triangles inside of the figure to count them out would be a challenge because of the tilt of the square. So I'm going to go ahead and I'm going to find the area of the entire white square. That one is really clear. I can count them out because it's not tilted. So that's the one outlined in black here. So I'm going to go ahead and do that. I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units across. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units down. So the big square has an area of 10 by 10, or 100 square units, right? And then I'm going to go ahead and identify those triangles, those 4 triangles on the exterior that are created, just as I did in the warm-up problem. So this triangle here has a base of 1 and a height of 10, right? Same thing I'm sorry, it's 9 actually, isn't it? 1, 2, let me count. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh boy, yeah, that's going to change things. Has a height of 9. Same thing across this little triangle here. Okay, that one has a base of 1 and a height of 9. It's just been rotated. And the same thing with this thin triangle on the side here, has a base of 1, height of 9. And finally, same concept with my last triangle at the bottom, base of 1, height of 9. Again, just rotated in another direction. So I'm going to calculate the area of one of those triangles at this time. Area equals 1/2 base times height. Okay, base was 1, height was 9. Again, I can do my multiplication in any order. I'm going to do 1 times 9. I get 9. Half of 9 is going to give me 4.5 or 4.5 square units. And again, there are 4 of these triangles. So I'm going to have to take 4.5 and either multiply it by 4 or add 4.5 to itself 4 times over. So I'm going to take that, multiply it by 4, okay? So if I have 4 groups of 4, I know that's 16, and then I have 4 groups of 0.5s or a half, that's another 2. So that would be 18 units squared. So the negative space is 18 units squared. The positive, or excuse me, the entire figure is 100 square units. So I want the blue space inside, so again, I'm going to need to take 100 square units and subtract 18 square units from it. So I'm going to take my total space of 100 and subtract that negative space, those triangles that I don't need from it. And when I subtract the 2, I get 82 square units. So my blue space inside here is 82 square units for its area. At this time, if you need to pause the video and adjust your notes accordingly, if you got what I got, fabulous. If not, please fix things and add to your notes now. And when you're ready, we'll go on to number 2. All right, so let's take a look at a strategy for number 2. In problem 2, some of the grid has been removed, but I'm still able to figure out the large space again, right? So that big white square, okay? So I can still count that out because there's a grid surrounding it. So I know 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Again, this is a 10 by 10 square. Let me just double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we already know the area of that white square is 100 square units from our math over here, right? All right, so now, in order to calculate the figure, the blue figure inside, again, I do see triangles that I can utilize to help me, okay? So I can still use, even though I don't see the squares through it, I can still use the squares behind it to help me with my base and my height. So I count 1, 2, 3, 4, 5, has a base of 5 and a height of 1, 2, 3, 4, 5. Okay, and if I count the others, again, it's 5 by 5, 5 by 5. So I can use that similar strategy like I did with problem 1. Now I'm going to calculate the area of one of the triangles, multiply it by 4, and subtract it from the area of the entire figure, which was 100. So for my triangles, sorry again, I'm having technical issues with the smartboard. I'm going to go ahead and I'm going to input my base of 5 and my height of 5. Again, I can do the multiplication in any order I want. 5 times 5 is 25, right? Half of 25 is 12.5. So one of the triangles is 12.5 or 12.5 square units. And I need to know how big all 4 of, or excuse me, how much space all 4 of them takes up. So again, I'm going to take that and multiply it by 4. So we're going to do 4 groups of 12.5 or 12.5. And when doing so, I get 50 total square units of that negative space that I can take away to figure out what the blue shape is. So here I go. I'm going to take the entire figure, which was 100, right, our 10 by 10 square, and I'm going to subtract our 50 units of negative space from it, square units, to get 50 square units for our blue space. So this blue region contains a space of 50 square units. So when comparing the two figures, I can see that figure 1 is composed of more square units than figure 2. Now let's take a look at figure 3 when they take away the grid altogether. Oh, by the way, if you do need to pause the video and adjust your notes accordingly for figure 2, please do so and add to your notes at this time, and then you can go on to figure 3 when you're ready. All right, so with figure 3, this time, like I said, the grid had been taken away, but they do provide us with some numbers. So we can still apply the same concept of enclose and subtract the space we don't need to get the space that we do need. So again, I'm going to find the area of the entire white square first. So I know when I add up 7 plus 3, I get 10 in both directions. So again, we are working with a 10 by 10 large square. And we know the area of that is 100, right? 100 square units. All right, now I'm going to go ahead and again calculate the area of one triangle and then multiply it by 4 so I can find all of that negative white space. So the area of one triangle, 1/2 times base times height. Okay, the base here is 3. The height of this triangle is 7. And you can see wrapped all the way around, they are the same size. Base 3, height 7, all the way around for all 4 triangles. All right, again, I can do my multiplication in any order. I'm going to multiply 3 times 7 to get 21. And half of 21 gives us 10.5, right? Oops, sorry, I'm just going to bring the page down a little bit if it lets me. All right, so we've got our 10.5. And again, that's just for one of these white triangles here. And I need to know what is that negative space for all 4 of them. So I'm going to multiply my 10.5 times 4. Remember, 4 groups of 10 is 40, and then I have 4 groups of halves. So that would be 42 square units of negative space. So I'm going to take away that 42 square units from my total, my 100 square units, subtract them, right? And we know when we do 100 minus 42, we get 58 square units for our blue space, or for our blue square in the inside. Okay, so at this time, please check your work with mine. Again, if you need to add any of the math to your paper right now, or adjust or fix anything, if you maybe made a mistake, please do so now. And when you are ready, we can move right along here. Maybe if my mouse lets me. Oh my gosh. All right. So, what are some of the strategies that we use to find the area of the tilted squares? Okay, so let's take a look here. Some of them were rearranging in the beginning, or decomposing and rearranging. And we definitely needed to utilize finding the area of triangles using our formula. But the main new one that's really going to be beneficial and help us is this concept of surrounding and subtracting. So we're really looking at the negative space, so that white space that's not part of the shaded figure, that's not part of the shaded square. to help us find the area of those tilted squares. Because we know when the square is tilted, we can't just count it out on the grid like we can when the square is perfectly straight and takes up an even amount, perfect even amount of squares. So keep that in mind. We're going to bypass the Are You Ready for More today. All right, let's take a look at our next activity here. Sorry, let me move that. Okay, so you're going to have a few minutes, excuse me, to utilize these same strategies, these same concepts to do your best to find the areas of figures A, B, and C. Once you have found the areas of figures A, B, and C and answer the questions 1 through 3 below, go ahead and check your work with mine. So at this time, please pause and calculate the areas for these 3 figures. All right, with figure A, it's really a nice figure, right? It's a nice square because, again, we can just count out the side lengths. So I count 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So this is a 5 by 5 square, right? So in number 1, where it says, what is the side length of square A and what is its area? That one was very nice to work with and calculate. The side length is 5 units, right? And we know when we do 5 times 5, we get 25. So the area is 25 square units, okay? All right, so hopefully you got that for question 1. Now question 2 asks, what is the side length of square C and what is its area? Again, square C is a very nice square where we can count out the side lengths. I count 1, 2, 3, 4, 5, 6 by 1, 2, 3, 4, 5, 6. So this is a 6 by 6 square. So each side length is composed of 6 units, and its area would be 6 times 6, which is 36 square units in size. Now, question 3 asks us to calculate the area of B. So what happened in B, they took a square and they tilted it, right? So it is physically impossible to try to count out these sides because you've got these little pieces that are running through and it's on an angle, so we definitely can't use the method that we used for A and for C. So here's where we want to try our new strategy of surround and subtract. Currently, I don't see a square surrounding square B. So what that means is I'm going to have to create one myself. So I'm going to go ahead and create a square as close as possible, touching the corners, the vertices of figure B, so I can apply the surround and subtract model. So I know if I go up from this, here I am, I can keep going. I got to stop here so I can touch on my way down that vertice of square B. I'm going to keep going, stop here so I can connect back and touch that vertice that I started from with square B. Now I've created 4 familiar figures, right? We have 4 triangles that are all the same size. So we're going to use the surround and subtract method. First, let's figure out the area of the big square we just created, the one that we can nicely count out. So I'm going to do that, and I count 1, 2, 3, 4, 5, 6, 7 by 1, 2, 3, 4, 5, 6, 7. So I've created a 7 by 7 square, right? And I know, I'm going to move this back up, that 7, so here's my work for B, 7 times 7 for the area of that square is 49 square units. All right, now I have to calculate the area of one of our triangles. So this has a base of 1, 2, 3, and this has a height of 1, 2, 3, 4. And if I wrap all the way around, again, I have a 4 height, a 3 base, a 4 height, a 3 base, a 4 height, and a 3 base. So they are all the same size. So I just need to calculate the area of one of them using our formula. So 1/2 times 3 times 4. I can do 3 times 4 first if I want. I know that's 12, and half of 12 is 6. So one of the triangles is 6 square units. And again, there are 4 of them. So I need to multiply this by 4, right? So we get 6 times 4, which is 24 square units for all of the white triangles. So I'm going to take those white triangles, subtract it from the square I created. So that's 49 minus 24. So 49 minus 24 gives us an area of 25 square units. All right, so there's our area of figure B. And if we want to know what is one of the side lengths of figure B, what number, if it's a square, which it is, what number times itself is going to get to 25? Oh, well, it must be 5, right? 5 times 5 gets me back to 25. So therefore, I know the side length of B must be 25. Now, if you're not sure about that, here's where we can utilize our patty paper to check that we did this correct. So if you go ahead and trace square B, you already found the area to square A, which was 5 by 5. So that tells us square B, when we trace it and rotate it, it should align right on top of and be the same size as square A. At this time, if you need to pause the video, add to your notes, adjust things, especially for figure B here. Question number 3, please do so at this time. Sorry. Make sure you've got all that work showing the new square we created, the 7 by 7 square, and the area of one of the new triangles we created, and multiplying that area 6 by 4, and then taking 24 away from 49. So that's that whole enclose the figure. We enclosed square B with a square we could easily count out, and subtract the figures that we could easily find, such as the triangles. All right, so again, if you didn't catch that, answers there for 3, there they are. And as soon as you're done, you can go on and move to the next activity. All right, so with activity 2, it is a very similar activity. This time, all of our squares are tilted. So we're going to have to use this surround and subtract idea for all 3 of them. Okay, so go ahead, pause the video, work them out, take your time, make sure you're surrounding and subtracting properly. So if you need to go ahead and press play to check your work throughout, please do so. All right, so if I look at figure D, again, I am going to create a square and enclose square D so I can actually calculate its area properly. So the new square I created is 1, 2, 3, 4, 5, 6, a 6 by 6 square. Sorry again with my technology issues. And we know 6 times 6 is 36, so the square we created is 36 square units. Then we're going to calculate one of the triangles. So this is a base of 2 and a height of 1, 2, 3, 4. So I'm going to go ahead and take half of 2 times 4, right, to get the area of one of our triangles. Half of 2 is 1. 1 times 4 is 4. And then I need to remember, oh wait, there's 4 of these, right? So I have to take that area and multiply it by 4 to get a total space of 16 square units that need to get taken away from the 36. So now here is where I'm going to go ahead and do 36 minus 16, and I get an area of 20 square units for figure D. Okay, so go ahead, add to your notes if you need to at this time, if you didn't get what I got. All right, let's check out E. Again, that same concept, enclose the tilted square E so that I create a square I can easily use the grid and count out with. 1, 2, 3, 4, 5, 6, 7. So I've created a 7 by 7 square. And we know the area of a 7 by 7 square is 49 square units, right? And then we're going to go ahead and calculate the area of one of the triangles we just created. I see this has a base of 2 and a height of 1, 2, 3, 4, 5 units. So I'm going to go ahead and do 1/2 times 2 times 5, right? I can do it in any order. I'm going to do 2 times 5 first is 10. Half of 10 gives me 5. And again, I need to remember there are 4 of these triangles surrounding square E, so I have to multiply this by 4 to get an area of 20 square units for our missing negative space there that we need to take away from the 49 square units. So 49 was our hole with our triangle, or excuse me, our square we created, and we're taking away the 20 square units, which composes those triangles of negative space that we created. And when doing so, we get the space left over for figure E, square E, which is 29 square units. All right. If you did not get what I got, again, please add to your notes now and adjust them. And then we'll be ready to check figure F. So again, figure F, we have our third tilted square, impossible to count out. We're going to create and surround figure F with a square that we can count out. So here I go, drawing in my perfect square that surrounds it nicely, just touching the vertices of each vertice or each corner in figure F. Now I can count out how big of a square did I create? 1, 2, 3, 4, 5, 6, 7, 8. So I created an 8 by 8 square. We know 8 times 8 is 64, right? So that big square we created is 64 square units. And then I'm going to go ahead and find the base and the height of these 4 triangles that I have created that surround figure F. So I have a base of 1, 2, 3, and a height of 1, 2, 3, 4, 5. So each of these triangles, to calculate their areas, is 1/2 times 3 times 5. Again, I can do that any order I want. 3 times 5, 15. Half of 15 gives us 7.5 or 7.5. And again, I need to remember there are 4 of these, so I need to multiply my 7.5 by 4, and I get 30 square units for those triangular pieces that I'm going to take away from the perfect square of 64. Okay, so that blue square we created, 64 minus 30 leaves us with 34 square units. Okay, for figure F. So we found all the areas of D, E, and F. Which of these squares must have a side length that is greater than 5 but less than 6? So I know that a 5 by 5 square, right, is going to give me 25. So it's got to be something greater than 25. I also know that a 6 by 6 square is going to give me an area of 36 square units. So it has to be greater than 25, but less than 36. So which of these squares could possibly have a side length greater than 5 but less than 6? It could be figure E, or it could be figure F, right, based on our work here. So again, if we stop and think about it, 5 by 5 square has to be 25 square units. A 6 by 6 square has to be, oops, sorry about that. 6 by 6 square has to give us 36 square units. And both figures E and F fall between 25 and 36. D would be too small, right? So both E and F could have side lengths between 5 and 6, right? Based on our math here. Okay, so if you do need to add that to your notes, please do so now. Let's go ahead and take a look at our synthesis. So some key takeaways here from this activity is that if the area of a square is in between the areas of two other squares, then the side lengths are also in between, which in this case, the squares in this task can be reinforced by estimating with tracing paper. So you could always go back and trace one of the squares that we just did and make sure that it does fall, you know, between 5 perfect squares and 6. Make sure that you realize that tracing paper is just a way to estimate area, and our surround and subtract method will help us actually get an exact area. So we want to focus on that method. If there is time available today, I'm going to ask that you try activity 3, but this will be done through the digital version on our Google Classroom page. So if you have time and you got through this lesson pretty quickly, feel free, go on our Google Classroom page. The link is there, the directions are there, but it's just a nice digital applet that allows you to manipulate figures, and it just kind of reinforces what we've done. If not, that's okay, and we can go on to recapping the lesson, and then you can work on your cool down and turn that in. So if you have a square and you know its side length, how can you find the area? So we talked about a few different methods depending upon what type of square is given, right? So if we have it on grid paper, we can utilize finding familiar figures and calculating the area of those, or deconstructing and recomposing, but the main one that really helped us out is the surround and subtract. So we can create a perfect square and subtract those triangles from it to find the area of a square that's not perfect. How can you find the area of a square if you don't know the side lengths? So again, same concept. We can do that surround and subtract method to create those perfect squares. If you have a square and know the area, how can you find the side length? So that's where you have to think about it in inversely. So we know like a 5 by 5 square is going to give us an area of 25. So we know that really we're just doing the inverse of squaring something, which is square rooting. So that's where we're going to get to next. So we're going to think about how these square roots can help us. Or a 6 by 6 square, we know the square root of that, the area of that is 36. So the square root of 36 is 6, right? Or a 7 by 7 square gives us an area of 49. We square root that and we get 7. All right. You do have your lesson summary on pages 6 and 6. Feel free, read through that to reinforce our idea here. It says the area of a square with side length 12 units is 12 squared, or 12 times 12, which is 144 square units, right? The side length of a square with an area of 900 square units is 30 units, because we know 30 squared is going to get us to 900, or 30 times 30 is 900. Sometimes we want to find the area of a square, but we don't know the length. For example, how can we find the area of square ABCD? One way is to enclose the square with side lengths we do know, and then subtract. So if you look further down in your workbook on page 6, you will see them apply the enclose and subtract method, just as we did throughout this lesson. All right, so now is your opportunity to work on your 8.1 cool down. Utilize the enclose and subtract method to find the area of the tilted square ACEG. As soon as please show all your work, and as soon as you're done, you may turn it into the inbox. And
that will be it.